Okay, hello guys. What I am going to share with you is a quick demonstration of our new siPlanning tool for AutoCAD Plant 3D. First of all, just to let you know that I'm working in a demonstration environment that is necessary to test the product. I'm sure your environments look different, but I have some structures, I have some piping, which is all we need for this demonstration. If you do need this test environment, it is available to download. Simply, let's get into it. So one crucial thing that you do need to load first, once you have correctly installed the Sikla plugin, you'll have a Sikla tab within your workspace within Plant 3D. The difference to this plugin when compared to our Aviva E3D plugin is Support Manager. And when I open Support Manager, initially you'll get a loading screen. That will only be in the first instance. This allows navigation and selection of supports because the environment is different to Aviva's E3D. If you are familiar with E3D, we have a navigation tree on the left of our interface with a parent-child structure. So sites, zones, strews, subframes, etc. However, it's slightly different in Plant 3D. So we have devised a way to navigate similarly because this plugin is based on our successful and well-developed E3D plugin. So we had to have a similar navigation system. So the first thing I would advise always when using the plugin is to open Support Manager. You need to get into that habit if you do use the other plugin. So by activating this part of the tool, you can then use the Scan DWG button. We are working in this 3D test environment, DWG, to see if there are any Sikla made products in there from the plugin already. As you can see, this is blank. We just have a out of the box blank 3D environment. Okay, so the next thing I would like to do is let's just build a goalpost to support these 3 pipes. So what I will do is open Template Designer with a double click, park the Support Manager. This can go on your other screen, but I won't be able to record both, so I'll squeeze them all on. So with the Template Designer active, you'll see that we don't have a current active support, and we know this because there are no active support containers. And what do I mean by containers? So I want to first have a parent to add Sikla geometry to, and I do this by pressing the plus button. Okay, and you can see that now we have a default named Sikla support /001. Okay, and we can now scan our DWG to find this support container. There is no geometry within this container at the moment. It's just an empty container. Okay, just a name. It can be renamed, or we'll leave it as the default for now. And then since this is now active as our CE, this is an Aviva language, so current element, it means whatever is selected. Okay, we can then use the templates to build a secondary support. So what we want is this shape, so something like an H-frame, or we call it a goalpost, and I'll select this. And then once we do select, we then have tooltips appear on the end of our mouse and also down in the command line. Pick twice a section or wall, because we can build this from a wall, so it would stand perpendicular to a vertical wall, or we can do this on the ceiling or the floor. We're going to choose the floor, a concrete base. So I pick once, twice, and give it a second to load, and then we have a default frame built roughly around our geometry of my 2 clicks. And quite cleverly and instantaneously, we have a H-frame built around these generic clicks. If I then flick back to Support Manager and scan again, you can see our container now contains a support, okay, a secondary support. We can navigate around this support as we would normally using Plant 3D. One thing I want to highlight from the get-go is that during the early testing phase of this plugin, we have noticed that when users navigate the user interface, the graphic window using this view manipulation tool, we do have some errors pop up. So we advise you to not use this until we provide a hotfix for it. And in the meantime, navigate using the view cube, please. Okay. In short, what happens here is when we use this tool to create a elevation view or similar orthographic projection, it cuts the field of view. So in essence, we don't have a Y axis when we look, which throws off the plugin slightly. Unfortunately, that is something we're dealing with at the moment, and it should be fixed soon. But going forward, everything else manipulation-wise you can use your middle mouse button to pan. You can control the middle mouse button to skew, and Shift and your middle mouse button to rotate. That's fine. That has no effect. Okay. So let's change the view slightly. Let's look maybe in a right view. Okay. And then zoom in a bit more so we can see what we're looking at. So this is fine. We can do this. In fact, no, I'm going to scan back to an orthographic, isometric, excuse me, and manipulate our frame a little bit further. So make sure we are on the support and it is active, and we have the template loaded. It's worth pressing load if you do click on another support whilst viewing other details. Let's just make this the column distance a nice round figure. Let's just say 2.5 meters, and you'll see the support shrink. Let's move the support a little bit using the move construction tools within the template designer, and you'll see if I move closer that if I hover over without clicking the direction I want to move, you have a indication of what this direction will be. I'm in solid view at the minute, a rendered view, and these are in fact arrows, these little things that pop out, but in a render view they look like cylinders. But let's move it this direction here. And when we have this tool, so I've left clicked on this arrow, it by default 500 millimeters is the given standard move. You can see there's a silhouette popped up by how much this will move. If this isn't enough, you can manipulate this by just keying in another amount, and you can see it will move a little bit more. Let's go with 750, hit return, and our structure will move. If you zoom in and out, the shadowing or the silhouette of the previous support will disappear. To me, that looks about right, and we can check this by rotating our view a little bit using Shift and the mouse wheel. Yes, that looks about right for now. You can, of course, do it more precisely using global coordinates. So let's, is the bottom of pipe to top of steel approximate? Yeah, that looks about right. We're having no clashing at the moment. So what we can do, we can change this. So something, say, let's just say 750, and the crossbar will lower. Again, we have increased the distance between the top of the Sikla crossbar and the underside of pipe. So what I want to do now is add some pipe support, some primary attachments, okay? And to do this, we need to use our attachment designer. Attachments are what primary supports are called within Aviva, but know that this just means primary supports and pipe clamps within the Sikla catalog. So let's open attachment designer, initially double click, all three of these tools can run simultaneously, just running at a little bit of space at the moment. You can see we don't have a support to associate the primary supports to. So there's a couple ways to do this, but what I would advise is use this button here, which is support design mode. So create a primary attachment. By toggling it on, again, we get tooltips at the end of that mouse and in the command line. So we need to first pick a pipe or tubing, again, Aviva speak, and then a primary steel. So I'll hover over this pipe within Plant 3D, and because I have rollover tooltips active, I want to not click the structure underneath, but the pipe. So yes, left click that. And then secondarily, subsequent to that, I'll want to associate it with the crossbar. So similarly, I'll hover over, left click to click the crossbar, and there we have a primary support, which is in line and associated with the piping. I'll continue to do this. The tool turns itself off at the moment as a default because it is easier to then reactivate rather than accidentally create more piping supports. So I'm going to create another one as a default, leaving all the settings as they are. Click a pipe, and again associate it with a second click to the steelwork, and I'll do a third pipe and associate it with the crossbar of our secondary support. So we have 3 primary supports. How do we know they're associated? Well, if we click back to our template designer, one over it, it will reload, and now we have 3 primary supports attached and associated with this, given center line and clearance distances relevant in relation to the top of the crossbar. Okay, let me move in a little bit more to show you that. I'll close this temporarily. So there we have our 3 supports. Okay, and if I left click, you'll see, or even hover over, you can see a blue highlighted silhouette. This is the same for the geometry of the frame itself. Wherever your mouse rolls over and the template is what you're selecting or about to select. So the primary is the same. Okay. And let's say we want to increase now the primaries associated with the crossbar, they are directly linked in terms of geometry. So let's maybe increase this distance here to slightly, I don't know, 765. Okay, and zoom in and out a little bit. We can see that our crossbar changed. Let's do that a bit with a greater detail. Let's put this down to 700. I'd imagine that this pipe support may change. Let's see, 700. So we're lowering the crossbar and zoom in out a bit. We should see it changed. Yeah, the pipe supports have increased in height because they are height adjustable Sikla pipe supports. And here, similarly, you could do the same thing by changing the center line distance of the pipe or the pipe clearance. Okay. Also, bear in mind, again, at the moment, I need to rescan the file just to see the primary supports in the support manager. So scan DWG, and you can now see we have 3 primary pipe supports active, okay, within the model. Good. Yeah, I think that is all making sense so far. Let me rotate this a bit better and zoom in. Okay. Meanwhile, we can load the template and change some secondary steel parameters. At the moment when we built our frame, right at the very start, after we created the container, I didn't change the Sikla profile. I just left it as the default, which is Ciframo 80R 80 by 80 box section. Now, I can manipulate that in its entirety now, let's say I want the whole frame, because this field here is the entire frame, whereas optionally I can change parts of the frame using these profiles here. If I want to change the whole frame to Framo 100, it will say, do you want to replace all profiles loaded in the shape? Yes, I do. And we should, within a couple flicks, see the profile change. And then therefore the template also update. So we now have 100, 100, 100 profiles used within the template, okay? You can see that. Yeah. Okay. If we need to have a hybrid frame using 1, 2 or more profiles, let's say we want the crossbar, we want the columns to remain as F100 and the crossbar to be F80. So I will just change in this instance the crossbar to F80. And we know then that will consequently change the end connectors to reducing connectors. So they'll change from 100 to 100 connectors to 100 to 80 connectors, okay? And how do I know this? Well, there are two ways to check your designing on the fly. First is to use the on-the-fly design help. This is called a consistency check, a live consistency check, okay? Excuse me. So what we're seeing are some user-guided prompts in the red at the bottom here. Some of them are warnings, okay? Most of them, in fact, here are warnings. So the design could proceed. They're just enhancements to the design. For example, you can see it's mentioning cut lengths of 981. Because this is quite unlikely to be cut to that precision, I will change this to something nice, the column to, let's just say 1 meter. I'll do the same for the other side, 1 meter, and hit return. Okay, so that warning about the 981 cut length has been resolved. We also have some suggestions about changing the component parts. So what you're seeing in this Sikla design at the moment is a WBD, our end connector, and a profile. It's suggesting, there's no need to, but it's suggesting that we use a welded beam bracket. Okay, so that is a base plate which is welded to our upright. So let's do that for one of the connections. So these are the connections we're using on the crossbar. These are connections that we're using on the base plate columns. So we use this arrow. And let's do as suggested. And what this is, it will reduce 1 cut. It will save 1 cut from the construction. Okay, because the profile won't need to be cut because the TKO welded beam console comes off the shelf at set lengths of 400, 800, and 1200. So let's say we want a Traeger consola, a TKO F100 with anchors the floor. Okay. And we know, because it's just over 1 meter, it's saying, well, actually, there's a 1200 length. You may want to increase that or put it to a clearer cut. Let's put this to the full uncut length of 1200. Yeah, and do the same on the other side if we needed to, just for ease of fabrication. Okay, and the length, let's put this to the full uncut length of 1200. So then we've done as the design help has suggested. Again, this was not 100% necessary. It was just a guide, okay? And then the final expected pipe clearance is between 171 and 223 for our pipe shoes, but the actual clearance is 225. What this is saying is one of our pipe shoes here is extended too tall. And I can see it's this one here, is this pipe shoe here, because it extended with outside of its range. Okay, so let's drop this between what it suggests. It's telling you the lowest it can be is 170 mil clearance. This is underside, top of steel to underside of pipe height. So let's change that to 220. Okay, and because they're all linked, it should shrink the other crossbar as well, shrink the other height of the shoes. Okay, so that we shrunk this down to 220, that error has been removed, and all the other pipe shoes are within the height tolerance. Okay, this tolerance here. No issues right now within the design. Another way we can verify this, so that is a live check. There's no need to then enter to another checking process. But what I would recommend is at the end of your design, you would use what's called the consistency check. And we can access the consistency check if we're not doing it live using this button here or the consistency check tool within the ribbon. So let's click consistency check. And what that does, that will check the current element. Okay. And we don't have any failures or warnings or suggestions because we resolved them on the fly. And that's how I'd suggest to work. If I were to open the consistency check module like this, I can then navigate to other supports that I may have designed and check them at the same time. As it happens, we only have one support and all the issues have been resolved, so we have no warnings or failures. Okay, close this. So that means the support is able to be constructed physically and all is happy. Okay, all is good. If you wanted to see what components I used, we can do this also in two ways. So let's run a report MTO. Click report MTO. This error message will always pop up. It is not to be not of too much concern. It's just to remind you to do exactly what we just did. That is, resolve any warnings or errors before running an MTO. Okay. There is a function within the software to disable the ability to run a BOM until the errors are resolved. But as a designer, that can also be frustrating until you maybe get to IFC type level of completion of your project. So this is just a warning saying, please check your consistency checks and errors before running a BOM. But on the fly, a designer may wish to know what type of anchors are used or what type of profile was used. So let's say, okay, I'm aware of this. At the moment, our report tool is inactive. Sorry, is active, but we have nothing to report on. We need to tell the report tool what I want to run a BOM on. Okay. And as I said, we have one support within our model. So what I want to do is make this my current element. You can see Sikla support 1 is active, and use my plus tool to add in the CE, the current element. If I were to do add all, it will add all supports within our test environment. So if we had 50, we'd add 50 in one go. At the moment, I just want to see 1. So I would just say plus. Okay. If I need to remove this individual support or any that are listed, I would click on them in any specific order and remove. I'll add it back in. If I needed to remove all of them, if I accidentally added 25 and I wanted all 25 to be removed without individually selecting them, I can use remove all button. But let's just run a report on one of them, Sikla support 1. Now, before we run a report, there are some options here that will determine how your report is laid out and configured. I would like the report to be in English, not German. We are a German company, so these are the 2 languages available. I want my primary supports to be associated in this bill of materials also. Okay. I would like the units of measure to be in millimeters and kilograms, metric units. And now, before we run this, okay, what I would say as a designer is the quickest ad hoc way to run a material takeoff or view the material for a frame is to use the show on screen button. and this is instantaneous. So you will see that as to build this frame, the secondary steelwork will be listed in numerically 1, 2, 3, 4, 5. The Sikla part numbers are here. The quantity of these items is here. The descriptions, the cut lengths if relevant, the weight, and then the totalized weight if they're cut. Okay. The primary supports are listed alphanumerically, A, B, C. So that is the primary pipe supports. We have 3 listed on this frame. These are the part numbers, these are the descriptions, okay? Along with their size in metric and imperial. This is fine. You can have the primary supports listed also numerically. This is a setting within the plugin itself. The preferred for many of our projects is that we keep the primary supports listed alpha numerically, okay? Also have the number of screws required for the frame. These are of course not modeled. They are added automatically by the plugin itself. So for example, this connection here, the STA will require 8 screws, which is 4 to fix the back plate to the column and 4 to fix the horizontal to the connection itself. So 8 in total, okay? So we have 8 here, okay? So screws. And because we removed the end support here and changed this to a welded plate without an insert, we don't have any screws here. What I can demonstrate is if I were to change this back to the original design, which was a base plate with anchors, okay, plus a profile. Let's make it the same length just for completeness. And I want this to also be a base plate. This one here, oh, actually I have to use 2 different types of base plate. Let's use the same type and the same cut length of the profile. Okay, we can see the advice has come back to user TKO. Again, it can be still run. What I'll do is run my bill of materials again, show on screen, and you'll see that we have more screws this time, okay? Because 4 screws are required for each of this. So the 16 plus the 4 plus the floor gives us the total of the 24, okay? We also have more beam section, whereas instead of a TKO. But you can see it's a very quick way to create a on-the-fly bill of materials, and this can be screenshot or pasted to me if we ever have any issues about design and you want to confirm something. The other way to run a bill of materials is to output it to Excel. Now, this is the default path of where the Excel output will live. Okay, you can browse and put this anywhere on your desktop. But let's leave it where it is automatically going to be saved and click the show on screen button. Sorry, not that button, the other button, the create file button, okay? And give this a second. If you do have Excel open, it can block this. So make sure you're not active in a cell in it currently open in Excel. If you're wondering where your template is and why is it taking so long, it is likely that you have Excel open already and are within a cell or a formula. So this is the default out-of-the-box Sikla template for the MTO. Okay, run through the tabs very quickly. We only have 1 support in this, but so all the material listed on a project could be listed within this BOM, and it would be in the total quantity. So that is everything from primary supports to secondary material. The next tab is listed per support structure. Again, we only have 1, so if this was more than 1, you could use a filter here for support 1, 2, 3, 4, 5, etc., and filter. Per pipe support, these are just the primaries. You can see we have 3 primaries associated with this support. Cut list, when we have relevant cuts, this is why I changed it back to a cut, you can see that our beam section, my F100 columns, we have 2 of them and they're 1200 long. Okay. We also have the crossbar cut at 2480 millimeters long. We have 1 of them. Similar total cut lengths. This is per cut, then we have totalized cut lists here as well, amalgamated. Support lists, these are the primaries listed. Okay, so we have a DN150, a 200, a 300 associated with this frame if you needed to have that information. Piping report, at the moment, the attachments or the pipes are labeled unusually. This can be changed to say a KKS coding or whatever the product requires for your primaries or pipes to be labeled. But this is the name of the pipes. At the moment, the 3 pipes we have. Checks. Okay, so because I left the warning within there, we have still 2 warnings. So let me explain what that is. So because these 2 warnings were disregarded, which is in fact fine, the frame can be still built. The checks as per the entire design remain. That isn't to say there's anything wrong here. We can just, as Sikla or you as designers, review any warnings. What you don't want to have are errors. Okay, these are things that will block the physical fabrication of the supports. So warnings are at least acceptable if you choose to design this in a separate way. Errors are not. Okay, we have no errors, which is good. Okay, I will not save it in this instance. And that is really everything I'd like to show you today. We can also, let's cancel this. What's maybe worth demonstrating is if I zoom in onto the support itself, a primary support. I may need to move the crossbar up to do this, but let's go into Attachment Designer, click on this support here, and I want to change it from a pipe shoe, because the default is an industrial pipe shoe, but we have different types of fixation as well. So let's say we want a guided pipe shoe, then the shoe will have a lateral restraint. If we want it to be a fixed point, the bracketry changes to one of our Sikla fixed point brackets, so to restrain axial movement as well as lateral movement and lift, and so on and so forth. If we want to change the primary completely, whatever options are available determined by your type of fixing. So let's say we have a sliding support to get rid of the bracketry. If we want to change it to our double banded pipe support, any option that is physically able to clamp to the pipe will be selectable within this drop down. And we can do some training on what is appropriate here. As a guide, with a taller center line you want, or larger pipe, you would need 2 bands, and that's to facilitate the pipe grip being gripped and to help any thermal expansion. Okay, so let's say I would like a 6-inch double banded, so LCHV. It's worth pointing out that only supports that fit the size of the pipe be seen here. You don't have to go through the whole catalog. Okay, I'll change that, and our pipe support changes to a double banded one. Okay, and you can see that because I've selected a pipe shoe that is a double band, that it's not stretched its clearance. So what I could do here is load up my template designer and make sure I'm active in the support designer, load it, and we can see, zoom out a little bit, that, excuse me, let me just deselect this, that this support, the clearance, no, excuse me, this support, yes, is 220, okay? So the one I've chosen isn't in fact tall enough. Okay, so I wanted it to be an LCHV 200 that is what was picked by the system itself, meaning it has a higher top of steel to bottom of pipe. So if I reselect that, you can see that is within the selected range of the height of the pipe. Okay, very good. I hope that all makes sense. There is, in a nutshell, a fly through of the siPlanning tool for Plant 3D. Thanks for listening, guys. I hope this helps.